This is a mathematics question based upon sets and relations. They have defined a relation R to be circular if A related to B and B related to C together imply C related to A. So we already know three types of relations, that is reflexive, then we have symmetric, and we have transitive. And in addition to this, they have defined a new type of relation, that is circular. Let us understand what are all these. In reflexive, what do we have? A relates to A. Similarly, B relates to B, and so on. But in symmetric, what do we have? If A relates to B, then that implies B relates to A. Means vice versa. In transitive, what do we have? A relates to B and B relates to C, then they together imply that A also relates to C. And in the circular, which is a new type of relation that they have defined, they are saying that if A relates to B, B relates to C, then they together imply that C relates to A. So this is the only difference between transitive and circular. So now we have these four types of relations, and based upon this, from the given options, we need to determine that in which of these cases will S be an equivalence relation. When do we say that a relation is equivalence? When it is reflexive, symmetric, as well as transitive. All the three are satisfied. So let us check out. In the first option, it is saying that S is reflexive and it is symmetric. Then will it be equivalence? It is just reflexive, which means A relates to A, B relates to B, C relates to C. And it is symmetric, which means AB will imply BA and so on. But using these two, we cannot establish whether it will be transitive or not. It is not possible that such a relation will be transitive, because these reflexive and symmetric put together, they cannot derive transitive, because if that were true, then there was no need of transitive. Only if a relation was reflexive and symmetric, we would have said that it is equivalent. But that's not true. Hence, the first one will be not an equivalence relation. Then second one is saying that it is circular and symmetric. Now let us see if using these two, we can derive all the three. In this one, the relation is said to be circular and symmetric. So by symmetric, what do we mean? A relates to B implies B relates to A. And in circular, what do we mean? A relates to B, B relates to C. Put together, they imply C relates to A. So let us check that whether from these we can establish the reflexive and transitive properties or not. Now, as we can see, the relation is symmetric. So if this is able to determine C relates to A, then it would also be able to determine A relates to C, and that is what becomes our transitive property. So in this case, symmetric and transitive are both being satisfied, but the reflexive will not be satisfied. That will fail. Hence, we do not have all the three being satisfied, making it not an equivalence relation. Then in the same way, let us check out if in the option 3 we are able to derive all the three properties, all the three relations holding true or not. So in the third one, we are having the relation as reflexive and circular. It is reflexive, which means A will imply A relates to A and B relates to B. It is circular, implies that A relates to B, B relates to C. Put together, they imply C relates to A. Now here we can say that since it is reflexive, let us say A relates to A and A relates to B are put together. Then after applying the circular property on this, what this will derive? The last one derives the first one, which means it will derive B relates to A, which means we are able to derive the symmetric property. Combining these two, we are able to derive the third property, that is symmetric. Let us also check out if we can derive the transitive property or not. For that, what we can do? We know that it is reflexive and it is symmetric as well. So if we apply this in the circular property, it is able to derive C relates to A. And after combining it with this symmetric property, we will be able to say that it is also able to derive A relates to C. So A with B, B with C, they will be able to imply A relates to C. So that is our transitive property, which means we have derived all of them. Reflexive was already given and we derived symmetric plus transitive. So all the three are covered, and hence this implies that the relation is in this case becomes a equivalence relation. Let us also check out for the last one and see if it can also hold true. In the last one, it is given that it is both circular as well as transitive. So using that, what happens? It is transitive plus circular, which means A relates to B, B relates to C. Here implies, in case of transitive, it implies A relates to C, and the same thing in circular will imply C relates to A. So just using these two, we have to check if both symmetric as well as reflexive can be established. But as it can be seen over here, using these two, A relates to C and C relates to A, means the vice versa of each other can be derived, and that can take us to the symmetric property only, but reflexive will not be holding true. It cannot be established using these three. So since all of them are not being satisfied, even the last one fails to be a equivalence relation. So the only third option is correct. In this case, S is an equivalence relation. So we will go with option 3.